sequencer track and choose duplicate tracks and devices.
Close this.
Most of what we need for our second track is already in place now. I'll pan each mix channel left
Okay,
and right.
when we are looking at solving nonlinear systems of equations, we're working with equations that I showed you are not lines. For solving nonlinear systems of equations, we can actually again, use substitution or elimination. For each of the following, we're going to solve using substitution or elimination, and then use our graphing calculators to see the sketch of the graph. So looking at example 1, would you use substitution or elimination on this one?
There's nothing stopping me from customizing
Substitution. In fact, this one would be impossible to use elimination just because we have an x squared and not a y, so we can't, it would be impossible to use elimination. But looking at substitution, we can clearly take x plus 3 squared and plug that in for the variable y. And that would give us x plus 2 times quantity x plus 3 squared is equal to negative 2. Now think about your order of operations. Do we distribute the 2 in, or do we do the exponent first? Exponent. Exponent, parentheses, that comes before multiplication. So x plus 3 squared, that will turn into x squared plus 6x plus 9. And then we can apply that factor of 2 inside is equal to negative 2. So distribute the 2, and that gives us x plus 2x squared plus 12x plus 18 is equal to negative 2. Now what do we do that we see an x squared term and some linear terms? What would be our method of approach here? Set it equal to 0 and factor. Awesome. So we take x and 12x, combine those, we have 2x squared plus 13x. We're going to set this equal to 0, so add the 2. And that would give us x squared, or 2x squared plus 13x plus 20 is equal to 0. Now you have two options. We could try to factor or quadratic formula. I'll go ahead and try to factor this.
Have you ever seen piano players
2x times x would give us x squared. The last term's positive, so we know that it's going to be the same signs as the middle term, plus and plus. And was anybody able to look at the factors of 20? 5 and 4. If we make the 5 here and the 4 here, that would give us 8x plus 5x, which would give us that 13x. Awesome. We set both of these equal to 0 and solve. So I have 2x plus 5 equals 0, x equals negative 4 for this one, and then subtract 5 and divide by 2, and we get x is equal to negative 5 halves.
I'll activate the root node on step 2.
So what this means is that I have two answers for x. So I'm going to plug in and find what would be those points of intersection. What's the corresponding y value when x takes on both of these values? So looking up at the top here, I'm going to see when x is equal to negative 4, what is the correlating y value? So I would plug that in. Y is equal to negative 4 plus 3 squared. And negative 4 plus 3 is negative 1. Negative 1 squared would give me 1. So that means one solution point that I should see come up on my graph is negative 4, 1. And then when I plug in x as negative 5 halves, I have y is equal to negative 5 halves plus 3 squared. If I think of that as negative 5 halves plus 6 halves, then that would be 1 half squared, and the correlating y value would equal 1/4. So that means if I'm looking at the ordered pair, my other answer would be when x is negative 5 halves, y would be 1/4.
Themselves are being generated using a player.
All right. Now the next part of the instruction said use your calculator to confirm these points. So I'm going to take, and this will be kind of my calculator part. In your calculator, we're always going to be solving for y, because we're going to be plugging y1 as the first equation, which is nice, is already isolated, x plus 3 squared. y2 would be the second equation, so I'm going to have to take that second equation, which is x plus 2y equals negative 2, and solve for y. So subtract x, negative x minus 2, divide everything by 2, and I have y is equal to negative 1/2 x minus 1. So this is what I'll enter in as my y2. Visually, it might be helpful for me to think what types of graphs should I get on my calculator. So what type of graph should the first one be? A parabola, good. It should be facing up. And what type of graph should the second one be?
Echoing the notes going in to play that instrument. Let me show you what I mean.
So just visually confirming, will this be what's on my calculator? So go ahead and take your calculator out. Let's confirm this graph here.
Now when I play a note on my MIDI keyboard, it first passes through note echo. Where, just like a traditional
now, even if I didn't have my calculator on me, think about the parabola. X plus 3 is in the parentheses. What does that mean about how the original shape, like this, how would that be shifted?
When I press one note,
to the left 3, so 1, 2, 3, there would be my point of origin. There's no number in front of the parentheses, so I know that this is not shrunk or widened in any way. Just kind of revisiting what we've learned in the past. So even before I take out my calculator, I know that it should look just like that nice parabolic shape that matches the parent graph. And then the line, even if I didn't have my calculator on me, I know that it has a y-intercept at negative 1 and a slope of negative 1/2, up 1, left 2, up 1, left 2. And even before I grab my calculator, I can confirm those 2 points that I found at negative 4, 1 and negative 5/2, 1/4. Negative 5/2, 1/4. But let's go ahead and, a lot of you grabbed your calculator already. We'll just confirm that on the calculator. So we have quantity x plus 3 squared and the negative 1/2 x minus 1. And when we graph that, we can see the same thing.
It's like each note repetition is striking the piano harder and harder, or softer and softer.
And then just a quick reminder, guys, I know we've done stuff like this in the past, but what would we do on the calculator to find those points of intersection?
One technique is to not actually
second trace number 5. Yeah, intersect, and we're going to have to do this twice. So we go to where we want to be on the first curve. Right now I'm at the point 4, or the x value of 4, so I need to move all the way over until I get closer to an x value of negative 2. Enter, 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 and I can see that first point of intersection is negative 2.5, and then, so that's negative 2.5, 1/4, and then do that again, and I can confirm that on my calculator with the other point, which is 4, or negative 4, 1. Any questions on that process before we jump into just kind of different types of graphs?
Turning this into
Alright, let's take a look at this next one then. Number 2,
if we increase the repeats
this one, what do you think would be more helpful to do? Elimination or substitution? Elimination, good, because they're already lined up. I have an x squared and a y squared. What would I multiply this through by? What do you guys want to eliminate, x or y first? I heard different. Raise your hand if you want x. Oh, raise your hand if you want y. Raise your hand if you don't care. Okay, let's do x. Alright, so if I multiply both sides by, or what would I multiply the top equation by to eliminate x? Negative 2. So that would give me negative 2x squared minus 2y squared is equal to negative 8. And the bottom equation would be the same. Remember, with elimination, make sure that you always add straight down. So the x's do eliminate, and I have negative 5y squared is equal to negative 20. Divide both pieces by negative 5, and I get y squared is equal to 4. So what should be my answer for y? Yes, I love you guys. You all said plus or minus 2. Here's the thing, if you had just said positive 2, you would miss an entire answer. Now, when I'm looking at this, I have to look at two cases. When y is equal to 2, what's my correlating x value? And when y is equal to -2, what's my correlating x value? So I'm going to plug y in as 2, and I have x squared plus 2 squared would equal 4. Plug that into the original equation. So that gives me x squared plus 4 equals 4. So x squared is equal to 0.
You can load many different options.
So x equals 0. Now be careful. How would I list my ordered pair?
Let's revisit the step
0, 2. So make sure you see that we solve for y, so that's our correlating y value. And then when y is equal to -2, it would actually end up being the same thing, but just so that we can see, we do have to take into account that this is two separate points as answers. So x squared plus 4 equals 4, x squared equals 0, so our solution is 0, -2.
Much the same way I might work with a step.
Now we're going to take a look at how would you solve this on the calculator, which is a little bit more complex just because we have some squared pieces involved. Before I look at the calculator, we should recognize what the first equation's graph should be. What should the first equation be?
This
is a circle. What's the radius? Just review. Radius is 2. What's the center?
Blend the triangle wave into the patch.
What's being subtracted from x and y? 0, so 0, 0 is our center. Remember, x minus h squared plus y minus k squared equals r squared. Center is your hk. That's just kind of some review thrown in there. Number 2, you have not seen the graph of yet. This would be a hyperbola, just so you know. It's going to be facing down and up. But we're going to look at how you can see the calculator, use your graphing calculator to develop that graph. So let's go ahead and let's bring these equations over. What variable are we going to have to solve for in solving on the calculator? Y. So we have x squared plus y squared equals 4. I'm going to solve for y, so subtract x squared. Y squared equals 4 minus x squared. Take the square root. Now here's where it gets tricky. How many equations am I going to have to plug into my calculator to represent this graph? 2. I'm going to have to plug in a y1 as the positive square root of 4 minus x squared, and y2 as the opposite of the square root of 4 minus x squared. Now, one thing that I do want to make sure that you are aware of, Facebook, I don't know what that is. Square root of 4 minus x squared and -4 minus x squared, there is a shortcut that you could use for your calculator. If you plug this in as y1, if you press alpha trace, it will access your F4. So in this, I could press, and I'll show you guys this. But I'll press the opposite, and if I go to alpha trace, I can select the y1 that I've entered in that equation, and then I can just do the opposite of y1. So let's do that so I can show it to you. I'll change the source of this, and then we'll go on to solve for that second equation. But if I look at this as y equals, I would type in the positive square root of 4 minus x squared. And you guys can see that. And now if I clear this out, I can do negative, and then press alpha, trace, and notice selection number 1 is my y1. That's saying I want to take the opposite of the equation I've plugged in y1. This can get can be very, very helpful as your equations start getting lots of weird fractions and you don't want to retype it all in. So now if I graph this, I should see the equation of a circle. Now notice on your calculator it doesn't quite connect the circle, just because the pixels are getting so small there the calculator can't really show it. If I zoomed in, I should see that circle shape connecting all the way to those points 2, 0 and -2, 0.
So far, no.
Any questions on that?
But watch what happens if I turn off the tempo sync.
All right, then let's go ahead and let's solve for that second y, and we'll go ahead and just finish finding the points of intersection of this problem, and then I'll let you guys try the next one with your partner. So looking at the second equation, 2x squared minus 3y squared equals -12. I'm going to go ahead and solve this for y.
Whatever
So
root
kind of
note
bring
you
this
play
over
results
here.
in a major chord.
So I have negative 3y squared
Parallel style chords are nice for
equals
house music,
negative 2x squared minus 12.
chords that are fitting
Divide
for
everything by
scale.
negative
If
3.
only there was some kind of player device
And I have
X
y
notes
squared
outside of
is
my
equal to,
melody.
we
Yeah,
could
of course,
simplify
right.
the negatives
That's
because a
exactly
negative
what
divided
scales
by a
and
negative
chords
is a
does.
positive. Or
We
you
can
could
add a
keep the
scales and
negative in there
chords
since we're
player
just
underneath
plugging
our
it
note
in
echo.
on our
Disable
calculator.
the chord
You can
switch so
decide
that
there.
scales and chords is simply adjusting the
But the
strum of
negative
notes
divided by the
coming
negative
out
is
of
the
note echo
positive. So I'll just
to
go
our
ahead
sounds
and,
K, B flat minor.
thank you, and fix this as 2x
And if we
squared
change the
plus
root
12
note, you can hear
over
the
3.
chords stay inside the key of
And
B
then when I
flat
take the
minor,
square roots,
while still
I'm going to have to
changing
plug in two
different
things. In
diatonic
y3,
chords.
I'm going to have to plug in
What
this
I love
function,
about this technique
2x
is
squared
that you can explore
plus
the many
12
cool
divided by
voicings
3.
that happen when
And in
scales and
y4,
chords shifts the
I'll plug in the
interval
opposite of
the
that.
chord is necessary.
Square root of 2x squared
Sometimes you get a simple
plus
minor
12
chord.
divided by 3.
Sometimes you get
But
a
again, I
suspended
can use
chord.
that shortcut on my
And
calculator
sometimes
of that
even diminished
alpha
chords.
trace to select
And the great news is
any
that it's up
any
to
y
you
that
to
I'd like
explore
to.
the really
So
colorful
let's
chord
see,
progressions you
source.
can create this way.
Oh, change that. See the calculator. So I'm going to plug this in. I'm going to do the square root of, I'll make a fraction, alpha y equals 2x squared plus 12 divided by 3. And then for y4, I can just take the opposite
So like
of
I said
my
from the start, note echo isn't tough to
y3
learn, but it still
equation.
has
So
enormous
again,
creative
alpha
potential
trace, but now I'm going to
dive
select
deeper
option
and deeper
3.
into it. I hope I've got you started today.
And now I should have that graph in for my calculator. So I press graph. Here comes my hyperbola. Notice you've got that coming up there. And my other hyperbola piece, which is
Today, we're going to look
right
at using VST
there.
instruments and effects inside Reason. If you've been making music with Reason for a while,
Now I might want to
you know how
zoom
much
in a little bit here.
But here's the coolest part.
Zoom
It's really no
in,
change at all.
Where should be our points at? Okay, yeah, 0, 2, and 0, negative 2. So if you wanted to zoom in just slightly so you can see those point of intersections, there's that 0, 2, and there's that circle. Notice if we zoom in, we see a better shape of a circle. And now I can see that hyperbola.
Together using all of Reason's rack device types from Reason devices,
Zoom in.
rack extensions, players.
And now what am I going to do to find those point of intersections? Press second trace. I gotta wait till it's done graphing. Second trace. Go to intersect. Now here is something that might be valuable to you as you're using your calculator. The down and up arrow jumps between functions, and whichever function you are on will show you the color at the bottom of the screen. So right now I'm on the blue function. I'm going to press enter, and I want to see where does the blue function and the black function intersect. So I want to make sure that I'm on the black curve. Notice how my calculator at the bottom is now in black. So press enter, and then make a guess, press enter, and it shows me that point of intersection as soon as it's done calculating. Is at, now this value is so close to 0, times 10 to the negative 6, we call it 0. So y is 2 and x is 0. And the exact value we saw algebraically is 0. It's just your calculator has to get as close as possible based off of the way that we have the screen, and so that's why it says it's about 0. And then we do it again, second trace, option 5, and now I'm going to jump to the pink curve and the red curve, and press enter, and then I can see it's at 0, negative 2 as well. So this is what you should see on your calculator. Let's switch that over. This video is going to be a little bit awkward because you can't see my calculator on the screen. But what I'm looking at here is I have a circle here, and then I have that hyperbola. I'll come around and see what happened on the calculator. But these are our 2 points of intersection, 0, 2, and 0, negative 2.
Displayed in our browser alongside our other rack devices.
That's so close to 0, times 10 to the negative 6. So that's the same thing.
Take a screenshot of your VST.
Okay, guys, I know a lot of you are still working, but I just want to stop here because I've seen a few mistakes in algebra work. So before we continue, I don't want to continue incorrectly. So first thing that I saw many people do is either solve for x or y, which is great, and substitute it into the other equation. Then when we get to this point, what can we do to get y squared out of the denominator? Good. Multiply both sides by y squared. Because when I distribute that in, that'll eliminate these fractions. Y squared goes into itself one time. So that would be 36y squared plus 4y to the fourth is equal to 25y squared. And then those of you who got here, what did you do next?
Then click the parameter you want to control.
Oh, sorry. Thank you. 36. Thank you.
Where you can choose your controller and which knob or fader.
Yep, we subtract, set it equal to 0. So we would have 4y to the fourth minus 25y squared minus 36 is equal to 0. What would we do from this point? Ah, sorry guys, I'm making mistakes all over. Thank you for catching that. What would we do from that point then? Yeah, you could either use substitution, or if you feel comfortable just factoring with a y to the fourth, that's fine. If you wanted to let u replace y squared, then you could see this as a 4u squared minus 25u plus 36 equals 0. And then you could use the quadratic formula to solve for u, or you could factor. Factoring this one, when I was first looking at it, I kept trying 2u and 2u, and you guys would find that doesn't factor, but if you look at it as 4u, and u, the last term's positive, so we know we're going to have the same sign as the middle term. And then what would you guys use to combine with 4u and u? It should be, yep, 4 and 9. If we make this a 4, negative 16u plus negative 9u would give you that negative 25u. And now we set each of these equal to 0. 4u minus 9 equals 0. And u minus 4 equals 0. We could solve for u, so we get 4u equals 9. So u is equal to 9/4. And u is equal to 4. But I do have to pop y squared back in here so that I can go on to solve for y. So y squared equals 9/4. Y squared is equal to 4. Take the square root, and what are my answers for y? For the plus or minus, good. Plus or minus 2, and square root, I get plus or minus 3 over 2. Which means I'm going to have to plug in 4 values for y, or at least take into consideration 4 values for y, and I determine what are my corresponding x values. So if I plug in a positive 2 in for y, and I would do it to this equation, just because it seems nice and easy to use. When y is 2, then I would have x times 2 equals 6. So x equals 3. So I have 1 point as 3, 2. When y is negative 2, then I have x times negative 2 equals 6. So I have x is equal to negative 3. So that's negative 3, negative 2. Now one thing to be careful with, don't just say plus or minus 3, plus or minus 2. Because if we say it in that way, then you could look at it as positive 3 being paired with negative 2, and which obviously is not a solution here. It's an ordered pair on a graph. 3, 2. And negative 3, negative 2. And then also we need to plug in that 3/2 and negative 3/2. So when y is equal to 3/2, then we have x times 3/2 is equal to 6. We could multiply by the reciprocal, so we get x is equal to 6 times 3/2, which would be 18/2, which would be 9. No, sorry, 2/3. My bad. My goodness, I just should not do math today. So 6 times 2/3, 12 divided by 3 gives me 4. Have to multiply by the reciprocal. And then also, so there's our point, 4 3/2.
I'll click Learn on the CV parameters first.
And then when y is equal to negative 3/2,
and click its frequency knob.
Then we have x times negative 3/2 is equal to 6. Multiply by the reciprocal, and we get x is equal to 6 times negative 2/3, which gives me negative 4. So I have the other point, negative 4, negative 3/2.
And also its base value. This base value represents where the VST plugin's parameter is.
Okay, if you could solve this for y and graph this on your calculator and confirm the points of intersection, I want to walk around and make sure that you all know how to use that calculator well.
If I adjust the EQ band in the
reflected this one in this way. If you need help, we're gonna have probably about 30 minutes of group work or time to work on the group work, so please let me know if you still need help on the calculator. Let's go ahead and let's take a look at this last one. What do you think would be easiest to use on this one, substitution or elimination? Elimination, what would we multiply the bottom equation by to eliminate y? 3, good. So if I distribute the 3 in, then that would be a 3 over x squared minus 6 over y to the 4th is equal to 0. And looking at the first equation, that's still 4 over x squared plus 6 over y to the 4th is equal to 7/2. Add straight down. What is 4 over x squared plus 3 over x squared? Yes, 7 over x squared. They have a common denominator, so we combine the numerators. 6 over y to the 4th minus 6 over y to the 4th is 0, and 7/2 plus 0 is 7/2. Yes, how do we do that? How do you guys get that?
Also, in this Edit Y position mode, we can hold down the Command key on a Mac or Control on Windows.
You could look at it as it's an equal fraction. So if 7 is equal to 7, then x squared has to equal 2. The other way I've seen people look at it is do the cross product property. Some people feel more comfortable with that. So it would be 7 times 2 is equal to 7x squared.
There are several included patches.
So 14 equals 7x squared, divide by 7. You get 2 equals x squared. Take the square root. So yes, x is equal to a plus or minus root 2. We need to find the corresponding y value. So when x is equal to a positive root 2, what would come out to be the y coordinate? So we have 4 over root 2 squared, if I'm using the first equation, plus 6 over y to the 4th is equal to 7/2. What is root 2 squared? 2. What's 4 divided by 2? 2. So I have 2 plus 6 over y to the 4th equals 7/2. Subtract 2 to both sides, or you can think of that as 4/2. And you would have 6 over y to the 4th is equal to 3/2. Because if you think of this as 4/2, 7/2 minus 4/2 gives you the 3/2. Then what would you guys want to do from here?
Radical piano sample.
Cross product property, 6 times 2 equals, yeah, okay. So we have 12, 6 times 2, which is 12, is equal to 3y to the 4th. Divide by 3.
But let's focus our attention on this.
And we have 4 is equal to y to the 4th. Take the 4th root. Do I have to take into consideration a plus or minus if I take a 4th root? I do, because if I think about a negative number, like negative 2 to the 4th, negative 2 times negative 2 times negative 2 times negative 2 is a positive 16. So I do have to take into account that this y value could be positive or it could be negative, because when I fourth it, it could become the positive 4. So I do need a plus or minus. Now here's another question. Can this be simplified? I mean, can this be, yeah, can we write it in a simpler way? Yes, let's think about it in this way. If I think about plus or minus 4 to the 1/4
envelope like we did before, for simple back and forth motion like this, we can also use.
What could I rewrite number 4 as?
Set our assignment knob to LFO1, which is set up as a slow-moving sine wave. Dial in the amount.
Well, even if I think about it as this, if I look at 2 squared,
turn it up higher, and our wave now morphs
and look at 2 squared, look at 1/4 as raised to the 2 to the negative 2 even.
Modulation of the shape isn't the only type of shape.
Fourth root.
Each Europa engine has two modifiers which can alter the waveform in a variety of ways.
If I multiply two numbers, because if I raise an exponent to an exponent, we multiply. What's 2 to the first times 2 to the negative second simplified to?
Let's start with
2 to the negative first. So this actually simplifies to plus or minus 2 raised to the 2 to the negative first, aka the 1/2.
It folds the wave in upon itself. As I go up, each fold...
Well, it's just it can be simplified. So rather than writing it as 4 to the 1/4, we would want to rewrite it as plus or minus square root of 2. To square root it twice.
Let's now turn off modifier 2 and activate modifier 1.
Square root it twice.
Phase distort bends our waveform in either direction.
Okay, so our answer here is actually root 2 plus or minus root 2. So root 2, and root 2, negative 2.
Just like we did for the shape, we can use an LFO to modulate our modifier's amount over time. Let's use
the fourth root of 4 is equal to root 2. Yes. Well, I'm trying to think if there's a different way that I could look at it. I could even look at it as 4 raised to the 4 to the negative first, but that won't help me see as to simplify it. Or I could look at it, you have to look at it as a base of 2.
Now bends and morphs from both LFOs working together. And of course, let's not forget the wave folding we did with modifier 2.
Which would be the fourth root of 4, but how would you look at that as a simpler way? I'm just trying to show you how it simplifies to plus or minus root 2. But that's the best way I can see it, because when you multiply a number with the same base, then you add the exponents, and that's how you can see 2 to the negative first, which just simplifies to that 1/2.
We've got 2 more sections to our engine, but to explore those, let's check out another song.
But think about this. If we plug in x as negative root 2, it's going to square, so we're going to get the exact same answers. But you are right, Nate, that we do have to think about, well, what would happen then? We're going to get a y as a plus or minus root 2. So we do have, when x is negative root 2, then we have a positive root 2 answer. And when x is negative root 2, we do have a negative root 2 answer. So we have 4 solutions. This is one where you could write plus or minus root 2, comma, plus or minus root 2, because all combinations
For the wave table, I'll select a special style of wave.
All right, guys, we're going to stop there. You